Hey everyone, and welcome to the channel. So you've built a cool CrewAI agent, maybe doing some research or automating a task. That's awesome. But right now, it perhaps just runs on your machine. And the question is, how do you make it available for others to use or integrate it into a larger application? That's where deploying it as an API service comes in. In this video, we'll walk through how to take your existing CrewAI agent code and expose it as a serverless API endpoint in the cloud. We'll be using a platform called Itura for this example, which offers a free tier and makes deployment pretty straightforward. The really neat part is we'll connect it directly to our GitHub repository. This means whenever we push updates to our code, the deployed agent will get updated automatically. So we'll have continuous deployment right out of the box. Okay, so this is what we'll have at the end of this video. Starting from a typical CrewAI setup, we'll get a unique URL for our agent. Sending a post request to this URL will kick off our CrewAI agent to start executing. And we'll have a dashboard where we can monitor the execution progress, view logs, check metrics, and things like that. So let's get started. Just as an example to illustrate the process, let's assume you have a typical CrewAI setup. You have perhaps something like a main Python file, a main.py, which is the entry point for the agent. Inside there's a run function. This function sets up some initial inputs, maybe a topic for research or some parameters, and then calls the kickoff method on our CrewAI crew object. Now, to make this agent accessible over the web, we need an HTTP server. To create that layer, we'll use Flask, which, as I'm sure you know, is a really popular and simple Python web framework. First things first, we'll need to add Flask to our project's dependencies. By default, CrewAI comes with UV as the package manager. If we're using UV, we can just run the UV add Flask command in our terminal. And with that, we will have Flask added as a dependency to our project. Next, we need to modify the main .py file. We'll import the Flask class and also request and JSONify from Flask. Then we will create an instance of the Flask application itself. Now, the core change we need to make is turning our existing run function into an API endpoint. We do this by adding a Flask decorator right above the function definition, like so. This decorator tells Flask that any post requests coming into the /run path should be handled by this function. And to note, it is essential that our endpoint is listening to post requests at the /run path. This is the path that Itura Cloud will be looking for to trigger our agent. Okay, then inside the run function, we'll keep the logic that kicks off our crew. However, it's good practice to wrap the kickoff call in a try-except block. This way, if something goes wrong during the agent's execution, we can catch the error and report it back. Instead of just running the crew, the function will now return a response. If the crew runs successfully, we'll use Flask's JSONify function to return the output, maybe the raw result from the crew, as JSON. If an error occurs, we'll return a JSON response containing the error message. Note that in a typical Flask app, you'd often see a small block of code, like the one shown here at the end of the file. This can be handy for running the Flask server locally for testing, but it's not strictly needed for the cloud deployment itself. So you can just run your crew locally using the crew run command and only care about the Flask endpoint for the cloud deployment. Oh, and a quick note on inputs. While our example is using hard-coded inputs inside the run function, we can easily grab data sent in the post request body. We can typically access request.json within the run function to get that data and pass it along to our crew. But to keep it simple, we'll just use a hard-coded input for now. Okay, the Flask endpoint is now set up. But there is one more thing we need to do before we can deploy our agent. For the cloud platform to be able to run our agent, it needs to know all the Python packages our agent depends on. For that, we need to generate a requirements.txt file. Assuming you're using UV and have the dependencies listed in the Py project file, you can use a command like uv pip compile, which will create the requirements.txt file. So let's do that. And now we see that we have a requirements.txt file with all the dependencies that our agent needs. With the updated main.py, now a Flask app, and the requirements.txt file ready, we now have everything we need to deploy our agent to the cloud. Let's commit these changes and push them to our GitHub repository. The cloud platform, Itura Cloud, will pull the latest code from the repository and deploy the agent. Now for the deployment part, head over to the Itura platform, app.itura.ai. The first time you open the platform after signing up, you should see a wizard that guides you through the process of connecting your GitHub account and selecting the repository and branch containing your agent code. Here I have already connected my GitHub account. So I will just select the repository and the branch containing my agent code. I'll click on the Deploy button, which will take a couple of minutes to build the environment and get everything running. Okay, now the deployment is done. We'll see a screen like this. First, we can see that the platform has already created an API secret key for us. This key is important. Treat it like a password and keep it safe. We'll need it to authorize our requests to the agent. And while we are here, let's also add any environment variables that our agent needs. For our example, we'll need to add the OpenAI API key. So let's add that. These environment variables will be injected automatically when our agent runs. Now we can proceed to the agent's dashboard. Here we can see the agent's unique URL for its endpoint, ending in /run. We can use this URL to trigger the agent. All right, deployment complete, environment variables set. Let's run the agent. All we need to do is send an HTTP post request to the run endpoint URL we got from the platform. We can use tools like curl or any HTTP client library. Here I'll use curl to trigger the agent. Notice that we need to include an authorization header with our API key. We also generally need a content type header set to application JSON. If our agent expects inputs, we'll include those as a JSON payload in the request body. In this example, my agent runs without any inputs, so I'll just send an empty JSON object. As you can see here, when we send the request, we don't get the agent's final output in the response. This is intentional. The platform is designed to handle the agent's execution asynchronously, as it may take several minutes for the agent to complete. Instead, we'll get a 202 accepted response. This means the platform has received our request and queued the agent run. The response body will contain a unique run ID that we can use to check the status of the run later. So how do we check the progress or get the result? The platform provides another endpoint, usually /status/run ID. We can send a GET request to this URL, again including our authorization header. This will give us the current status of that specific run, whether it's pending, running, succeeded, or failed, and eventually the results if it succeeded. Note that we don't need to code this /status endpoint ourselves. The platform handles it for us out of the box. Alternatively, we can check the dashboard at app.itura.ai to monitor the run and see the logs. And that's basically it. We've deployed our CrewAI agent to a serverless cloud endpoint. It's now accessible via an API, ready to be integrated or used on demand. And remember, because we linked it to GitHub, if we need to update our agent's logic or add features, we should just push the code changes to our repository. The Itura platform will automatically pick them up and redeploy the new version. I hope you found this video helpful. If you did, please like and subscribe to the channel. And if you have any questions, please leave them in the comments below. Thanks for watching, and happy coding!